Alrighty, so this video is basically my attempt to work out a few example problems for vectors that we just learned in our last video. This should help understand a little bit more clearly the theory that I talked about last time and see it in action, kind of get a view and a feel for the thought process involved in solving some of these problems. And as I've been trying to make clear, it's very, very important that this particular topic you spend a lot of time practicing and a lot of time understanding so that it becomes second nature. So I'll start. Our first question, let's say vector A is a vector whose magnitude is, let's say, 5 meters and points at 30 degrees north of east. And I'd like to find the x and y components of vector A. Okay. So, first thing you can do is you can draw this out, get a feel for what this vector looks like. We've got 5 meters long, so here's an arrow 5 meters long, let's say, at an angle of 30 degrees north of east. So again, to make sure your angles are correct, first of all, if it's not specified north of east or anything like that, then when the angle is given, it's understood to mean 30 degrees with respect to the positive x-axis. Of course, this is x over here and y over here. So if I give you a vector, and I don't tell you west of south or anything like that, I just say 30 degrees, then it's understood that it's 30 degrees counterclockwise from the x-axis. But if I do tell you specifically 30 degrees north of east, the way you understand what that means is if it's north of east, that means you start east first, so east being the x-axis, and then you're going to move counterclockwise 30 degrees to the north. And so that's how this particular vector is pointing. All right, so that's what the vector looks like. And what am I looking for? I want the x and y components. So I can make a little right triangle out of this vector. One side is the x side, and the vertical side is the y side. And then we say, all right, now, in order to get x, I say, well, what do we have? We have a right triangle whose hypotenuse is 5. The angle is 30 degrees, and I want the x side. The x side in this case is the side adjacent to the angle. And SOHCAHTOA says that adjacent means cosine. So specifically, I'm going to do this the long way this time, and then in subsequent questions, just kind of shortcut it the way you should be thinking about it. But the long way is to say, okay, the ka part of SOHCAHTOA says cosine of theta is equal to the adjacent side over the hypotenuse. But notice for this particular question, I'm looking for the adjacent side. Okay, so I want to solve this expression for the adjacent. That means I move the hypotenuse over to the other side, leaving adjacent by itself, and I get adjacent equals hypotenuse times the cosine of theta. And now all I have to do is plug in the information from my problem. I'm looking for the adjacent side. That's called the x component. is equal to the hypotenuse, which is 5, times the cosine of the angle being 30 degrees. So then I get my calculator out. I say, all right, first of all, I make sure I'm in degree mode instead of radian mode. And then I do 5 times cosine 30. And I get 4.33. So there's my x component done. For the y component, of course, we're going to do the same thing. We're going to say y, that's this side over here. That's the side opposite to my angle. Opposite from SOHCAHTOA goes with the SO part, so that's sine. So it's a sine of theta equals the opposite side over the hypotenuse. So again, I want the opposite side, so this says opposite is hypotenuse times sine theta. Opposite for our particular problem is called AY, that's the y component. Hypotenuse is 5. Sine of 30, because the angle is 30. And again, I plug this in my calculator. 5 times the sine of 30 is 2.5. And now I have my y component. And so this is how you want to break a vector up into its x and y components. Generally speaking, either visually in your mind or on the paper, draw out what the vector looks like from the given information. Then create your right triangle out of it. Label which side is the x side and which side is the y side. Of course, x is always the horizontal side of the triangle and y is always the vertical side. Once you've done that, then you use the rules of trigonometry, SOHCAHTOA specifically, to figure out if you use sine or cosine to calculate your particular component. So let's try another one. Let's say vector B is a vector whose magnitude is 20 and is pointing at an angle of, let's say, 240 degrees. And again, the question is find the x and y components of B. All right, so let me draw this out so we can see what it looks like. Here's the x, here's the y. And then our vector B is an arrow that points at 240 degrees. So if you remember, this is 0, 90, 180, 270. So if the negative y-axis is 270, then 240 is somewhere over here. Where this angle here, the angle between 240 and 270, is of course 30 degrees. And the length of this arrow is 20 meters. Okay? So once you can draw that, then you're in the clear. Now all we have to do is create our little right triangle. Here, horizontal side, that's going to be called the x side. And here's the vertical side. That's called the y side. So, first we calculate the x component. We look at our triangle. The x side is the side which is opposite to the angle. Opposite means sine, so that means bx is going to be hypotenuse 20 times the sine of the angle 30. However, before we accept this, we also have to figure out, is this positive or is this negative? Well, our vector B is pointing down and to the left. So that means in the x direction, vector B is pointing leftwards, and left means it's negative for the x component. so I have to put a little negative out in front. Once done, now I just stick this stuff in my calculator. Negative 20 sine 30 is negative 10. And that's the x component of my vector b. I do the same for y. Y component, I look at my right triangle, the y side here, that side is next to or adjacent to the angle, and I know SOHCAHTOA says adjacent goes with cosine, so by is going to be 20, the hypotenuse, times the cosine of 30. And again, I question whether this is positive or negative. Vector b is pointing down and to the left, so in the y direction is pointing down, and so my y component must also be negative. So now I just stick that in my calculator, and I get negative 17.32. And I now have the y component done. So you can see from these two examples, every time you go to break a vector up into its components, you're going to be using the same method. Either the problem will give you the vector already drawn out, in which case you just make the right triangle, you figure out which side is x and which side is y, or the problem gives you information about the vector and you draw it out. Once you draw it out, again, you label your right triangle. One side is going to be a horizontal side, that's your x. One side is going to be vertical, that's your y. At that point, you look at the right triangle, you say, okay, for the x component, is that side adjacent or is it opposite? And remember, what that means is it adjacent to the angle or opposite to the angle? Once you see which one it is, then you use SOHCAHTOA to tell you if you use sine or cosine. Of course, if the x component is adjacent to the angle, then it's cosine. If it's opposite to the angle, then it's sine. And you can see in example 1, the x component used cosine, whereas in example 2, the x component used sine. So you can't always use just cosine for x and just sine for y. You have to see for your particular problem which you're going to use. Also, you have to be very careful about the signs. Is this a positive component or a negative component? In example 1, since the vector was pointing up and to the right, both the x and the y component were both positive. However, in example 2, we had a vector which points down and to the left. Left means the x is the negative, and down means y is negative. So you have to ask that every time you go do this. Once you've asked all those questions, and you have your little formula like this here done, then you can plug that into your calculator and get the answer. All right, so what other kinds of examples should we know how to do? Well, how about one where we're given two vectors and we need to add the two vectors together? So let's try this. Let's say a person walks 10 meters due east, then turns and walks 20 meters due north. How far from the starting point does the person finish? Okay. This is a classic sum of vectors type problem. We have two different vectors, a displacement or a distance traveled of 10 meters in one direction, and then after that 20 meters in another direction. and I want to know where they end up. So let's draw our two vectors. Here's x, here's y. All right, so our first vector, 10 meters due east. So start at the origin, and you draw an arrow due east. That means in the x direction, 10 meters. All right, the second vector is 20 meters due north. So I'll draw that in green. Now here's the thing, remember, even though in our minds we would say from his last location he now goes north, that's true, when we're drawing vectors, every vector must always start at the origin. So for the second vector, he also starts at the origin, and now he walks straight up north, twice as far, and that's what he does for the second part. So this is 20, and this is 10. Call this vector A, and this vector B. Now what is it I want to find? What I'd like to find is vector C, which is the sum of his motion in A plus his motion in B. That's what I want to do. The problem is vectors A and B do not point in the same direction. So you can see vector A points to the right and vector B points up. I can't add those two things together. So this is where the trick of breaking our vectors into components and then adding the components together to get our answer comes into play. So, if you have this question, you're given two vectors and you need to add them, but they don't point in the same direction. The very first step is for each vector to get the x and the y component. So, let's look at vector A first. I want to get ax, and then I want to get ay. So let's look at vector A. First thing I would do is I'd try to make a right triangle out of him. Of course, this is awkward because A is pointing straight to the right. He doesn't have an angle. The angle is 0. There is no right triangle here. Well, this actually makes it easier to do because we know that when we're asking what are the components, what it's actually asking is how much of vector A points in the x direction, or how much of vector A points in the y direction. That's really what you're asking when you want to find the components. Well, if you look at vector A, the whole thing is pointing in the x direction. There's no amount of A which points up and down. So that tells me the x component of vector A is 10, all of it, and none of it, 0, is in the y direction. So in this case, I did not have to use sines and cosines to figure this out because it was already on one of the axes. And when it's on one of the axes, you already know how much is in that direction. And the same holds for vector B. Let's look at vector B. Again, we want the x component of B and we want the y component of B. So we look at vector B, we try to make a right triangle out of him, but of course we see we can't really make a right triangle because he's at 90 degrees. He's straight up and down. There is no angle off of that axis. And furthermore, when you ask how much of vector B points in the x direction, you can see none of it points in the x direction. It's pointing completely straight up. So that means vector B's x component must be 0, and his y component must be the whole thing of 20. So that's pretty nice. We were able to figure out the components without the need of sines and cosines, just using logic, using a little intuition. If vector A is completely on the x-axis, then the whole vector is the x component, and none of it is the y component. And likewise for B. All right, so now we have the components completed. Now the rest of the problem is easy. All we do is we say, okay, see x, the x component of our final vector, is the sum of the x component of A plus the x component of B. So I just look at my components. Okay, AX is 10, BX is 0, So the total Cx is 10. And then Cy. Well, the y component of my final vector is the y component of A plus the y component of B. So I look at my components, AY, that's 0, BY, that's 20. So I get that CY must be 20. And now the final step, or set of steps, is I want to take these two components, CX and CY, and get the magnitude of C, which is how long the arrow is, how far away he is, and the direction, theta. In which direction does he point at his final location? So we remember, using the Pythagorean theorem, that the magnitude of C is always the square root of the x component of C squared plus the y component of C squared. So plug those numbers in. Cx squared, that's 10 squared, plus Cy squared is 20 squared. I'll plug those numbers into my calculator, and I get 22.36 meters. So that's how far away he is from the end point. If you were to start at his front door or wherever he started, you'd have to walk 22 meters to get to his final place. But in which direction should you walk? Straight to the right, straight up, which direction? So theta, that's the inverse tangent of the y component over the x component. So inverse tangent of Cy, that's 20, over Cx, that's 10. And again, I plug this into my calculator, and I get 63 degrees, 63.4, let's say. Well, before I box it, as always, I need to make sure this angle makes sense. So let's look at our components, Cx and Cy. What should this vector look like? I'll draw this in red. It's a vector which points to the right 10 and then 20 up. So it's somewhere this way. That should be my vector C. Does the 63.4 match that guess? Yes, it does. 63 degrees is in the first quadrant. Looking at the components is to the right and up. That's a first quadrant answer. So yes, this angle is perfectly fine. And now I know, if I want to follow this person's path, or not follow his path, but just walk directly to where they ended up from the starting point, I would follow this vector C, walking an angle of 63 degrees and a distance of 22 meters or so with the decimals, and I'll end up wherever he ended up. That's how you add vectors together. Again, the process. A lot of times, it's worthwhile to draw out the vectors so you can see the right triangles. So you take the information in your problem, you draw them on a little coordinate system. Once done, if you can, you draw the right triangles for each vector. Then, the first step after you've drawn it out is find the x and y components of all the vectors in the problem. So I have two vectors in this problem, a and b. I've found the x component and y component of a, and then the x and y component of b. So maybe you have to use sines and cosines. Maybe some of them happen to lie on an axis, so you could get them directly. Watch out for positives and negatives. Once all your components are laid out, then to get the x component of your final vector, you add the x components of each individual vector together. Ax plus bx gives you cx. And ay plus by gives you cy. You now have your final vector, x and y components. From there, to get the actual answer, all you have to do is get the magnitude, which is the Pythagorean theorem looking problem over here, and the direction, which is the inverse tangent equation. So those are two equations. You should memorize the heck out of them because you're going to use them all the time. Once you use the magnitude, you get an answer. That's a good answer. You could always box it, as long as, of course, you've plugged it in correctly. But you have to be careful when you look at the theta, the direction, because sometimes, even though you may plug everything in correctly, the answer you get is not the right answer. In this case, it happened to be the right answer, but half the time it won't. So what you do is you look at the components of your final vector. Here we have cx and cy. You say, okay, what does this vector look like? Well, it's something to the right and up, so it's somewhere that way. The answer I got from theta, that's first quadrant, 63 degrees. My guess, by looking at the components, was first quadrant. Since that matches, I'm fine with the angle. If, however, they didn't match, if looking at the components, it should be in the third quadrant, but my answer was first quadrant, then I know I would have to add 180 degrees to that answer to make it correct. All right, I'll do one more, where this time we'll have to use some components to figure out the answer. Let's say I've got my two vectors like this. In fact, I'll do three vectors. Let's say first vector, second vector, and third vector. All right, so let's say vector A is 5 meters due east. Vector B is 10 meters, 30 degrees west of south. And then vector C is 15 degrees, 30 degrees north of west. Okay. And so that's what the vectors look like. First step is all of the vectors, try to make a right triangle out of them. So vector C, since I'm on that color, we're going to have a vertical side and we're going to have a horizontal side. The vertical side is called CY and the horizontal side is called CX. Vector B also has a horizontal side and has a vertical side. The vertical side is called BY. Horizontal side is called BX. Vector A lies on the x-axis. So I can't make a right triangle, but I know since it's on the x-axis, the whole thing is x component. Once that's clear, I start doing my components. So let's look at A first. I need an AX and I need an AY. All right, so looking at vector A is a vector of 5 meters due east, which means all of vector A is in the x direction. So the x component is 5. And the y component must be 0 because none of vector A points upwards or downwards. Okay, vector B, I need a BX. So I look at vector B and I say, okay, BX, that's the horizontal side down here. That side is opposite to the angle. So that's opposite goes with sine. So vector B is going to be 10 sine 30. And then I make sure Vector B, does he point negative or positive in the x direction? Well, looking at vector B, that's pointing down and to the left. So in the x direction, he points leftwards. So this should be negative. And so I get Bx, plugging this in my calculator, is negative 5. Sorry, negative 5. And of course, By, likewise. By is the vertical side. That side is adjacent to the 30-degree angle. And I know from SOHCAHTOA, adjacent goes with cosine. So he's going to be 10 cosine 30. Is he positive or negative? Well, B points down and to the left. So in the y direction, he points down. And I know down is negative. So By then is negative 8.66. And finally, we have vector C. So for vector C, we need an x component. All right, x side of C, that's the side down here. That side is adjacent to the angle. Adjacent goes with cosine. So that's going to be 15 cosine 30. Okay, is he positive or negative? Note that vector C points up and to the left. Well, in the x direction, he points leftwards, so he's negative. So I plug this in my calculator, and that tells me Cx is negative 14.98. And then Cy, the y side over here, this side is opposite to the angle. So that's 15 sine 30. Positive or negative, vector C points up and to the left, and in the y direction that's up, and up is positive. So he's positive 7.5. All right, now the hard work is done. We've broken all three of our vectors into the x and y components. Now all that's left to do is use those components to get the x and y component of my final vector, vector D. So dx is ax plus bx plus cx, which is 5 minus 5 minus 14.98. So I get negative 14.98 as the final x component. And dy, of course, is ay plus by plus cy. Ay is 0, by is negative 8.66, and cy is positive 7.5. Plugging this in my calculator, I get that dy is negative 1.16. All right, good. We now have our final vector, vector D, but we only have the x and y components. So all that's left, find the magnitude and the direction. Magnitude. Magnitude of D is the square root of dx squared plus dy squared, always. All right, so dx squared, that's negative 14.98, that whole thing squared, plus negative 1.16 squared. All right, plugging all of this in my calculator, I get 15.02. All right, so the magnitude of D, that is the total distance, or whatever it is we're calculating, 15.02. But now we need to know in which direction does this vector point. Theta. Theta is inverse tangent of the y component over the x component. All right, so inverse tangent of dy, which is negative 1.16, over dx, negative 14.98. So I'll plug this in my calculator. And I get 0.61 degrees. All right, and then before I box this as my answer, let's see if this makes sense. What do I have for my components if I were to draw this out? Okay, here's a little sketch. dx, negative 15, so that means you go to the left 15, and then dy is negative 1, so you go down 1. So that's something like this. That's what vector D kind of looks like. So that's third quadrant. However, the answer I got was 0.6. 0.6, that's something like this. Very, very close to 0. That's a first quadrant answer. So they don't match. Since they don't match, I know all I have to do is add 180 degrees to this. So my real answer for the angle is 180.61 degrees. Okay? You have to be very careful, especially on tests, as you're rushing along trying to finish up the test in the time allotted. It's easy to box the answer as soon as you get it and move on to the next question. But you have to take the extra 5 or 10 seconds to compare the angle you get from the equation with what you think the answer should look like. In this case, looking at the x and y components of D, the final answer, it looks like it should be somewhere in the third quadrant. The answer I got, however, was first quadrant. Since they don't match, I add 180 degrees. Once I add 180, then I know I have the right answer. So this is vectors. This is what you're going to be doing for the rest of the semester and next semester as well. You're going to be given vectors in your problems. You have to manipulate these vectors, but in order to manipulate them, the very first thing you're going to have to do is break all your vectors up into x and y components. So, just like at the beginning, given a vector, can you figure out the x and y components of that vector? Let's see, this obviously got erased by accident. This said adjacent over hypotenuse. How do you figure out whether it's sine or cosine? You make a little right triangle out of your vector, one side being the horizontal side, that's x, one side being vertical, that's y. And then you look at the triangle and say, does the x side, is that adjacent to my angle or is it opposite to my angle? If it's adjacent, then you use cosine from SOHCAHTOA. If it's opposite, you use sine. And then also, is this component a positive component or a negative component? You'll look at your vector. Which way does the vector point? In this case, vector A pointing up and to the right. So that means for the x component, he's pointing rightwards, so that's positive. And in the y direction, he's pointing upwards. That's positive as well. And you would do that for every single vector in your problem. After you do that, you now have your vectors broken up into components. If the rest of the problem says you need to add the vectors together to get your answer, then what you do is you add all the x components together to get a final x, and you add all the y components together to get a final y. With that information, you can then get your magnitude and direction done. The very last thing is for the direction, just to have that little check at the end to see, does the direction match what you know it should be? If it does, good, you box the answer. If it's in a different quadrant, you add 180 degrees, then you're okay. So, I hope this is helpful. Take the time to practice the rest of the practice problems that are on Canvas right now. Work them out over and over and over again till you're sick of them. That way, when we get to physics problems, this part of the problem won't be a big deal to you. You'll have this down pat, and you'll be able to focus more on how to mess with the equations and so forth. As always, if you have any questions, feel free to let me know, and I wish you luck.